The 5.11 lesson is mostly going to have to do with a Nearpod, so you are going to want to check Canvas for the link and the code to get into this Nearpod. It's going to be very difficult to do it without. So the one you can see on my screen right now is not going to work for you. You do need to check the Canvas link to do that Nearpod. I will put it up in this section, so you don't even have to click away from this, but you need to have the Nearpod. So, with this Nearpod, most of what you're going to be doing today is really just looking at something and figuring it out. In class, I did have them working with their sentence frames that I gave you guys. I gave you all a little green sheet with sentence frames on them at one point. Okay, so to understand the problem, it looks like, I noticed that. Those are going to be really useful for you today. So if you're trying to express your thinking, those are good things to use. You're also going to want to use a lot of the to explain section. So I noticed blank, so I blank. I tried blank. And what happened was, you're going to want to be able to use those. It will make this particular lesson a lot easier for you. So the notes for 5.11, I do want to show this to you. This is just workspace for you guys to show your thinking and to jot stuff down that you need for the Nearpod. Okay, so the Nearpod is really where everything is. The notes are just there for you to be able to write something down and work things out in your brain. So the first one I showed everybody in class was this, and I asked them, what do you notice? What do you see? What's different about these two things? What's similar about these two things? So hopefully you were able to see this one fairly quickly. We have 2 squares and 3 circles equals 18.5, or 2 squares and 2 circles equals 14, and we're trying to figure out, well, okay, what does 1 circle equal? So I'm going to bring this in here. I want to crop that though. We don't need all of this stuff. Just this. Okay. So if we have this in here, what most people noticed right off the bat was that these are the same. These are different, and these are different. So the only difference really on this top one is that there's this extra circle. But we also notice that these numbers aren't the same. So one way I like to show you guys to think about this, or to write down your thinking, is to say, okay, how do we get from here to here? Well, we minused a circle. And how did we get from here to here? Well, we minused 4.5. Now this is an equation. So I want you guys to think about, what do you know about equations? Hopefully you know that if you minus 4.5 from one side, you also need to minus 4.5 from the other side. But we didn't. We minused a circle. So what does that mean? Well, that means that one circle would equal 4.5. Because if minusing a circle and minusing 4.5 are the same, then it would keep that equality. That's important. Okay? All right, so let's go ahead and move on to the next one in the Nearpod. So this one's a little bit trickier, but not too bad. Okay, so I want you guys to try this one out and see. Again, you're going to want to see, what do you notice? What does that mean? What should you do first? What should you do next? So I'm going to give a lot of pause time and think time today. Please, please, please feel free to pause the video and think as long as you need to. Okay. The same thing, I want you to look and see, what do you notice? What's the same? What's different? What's going on here? Oh, and for the record, this is a completely separate problem. So I know that the circles equaled 4.5 over here. That does not mean that they equal 4.5 here. Okay. So I think most people were pretty quick to see this one too. The difference is these 2 squares. Okay. We've got 3 circles, that's the same. But we've got 4 squares here, 2 extra there, and then we've got 43 and 54 that are different. Okay. So again, how do we get from here to here? Well, we add 2 squares. And how do we get from here to here? You can think about how you get from here to here also, but that's plus 0, and we don't usually write plus zeros in math. They're not usually super helpful. So 43 to 54 would be adding 11. So that tells us that the 2 squares need to equal 11. Well, if 2 squares equal 11, what does that mean about what 1 square equals? Hopefully you were able to get that. It would be half of it, which is 5.5. Okay. All right, next. This one is harder. You are going to need to take more time to figure this one out. I promise. Okay, this one is a little bit more complicated. So you really need to think about, what do I notice? What do I see? What could I possibly do to figure this out? And I know that these are hard, guys. I'm fully aware, and it's hard for everybody in class too, but everybody in class was able to do this with me, and was really able to invest in their own learning, and it was really awesome, and it was a really good time. And I'm sad you weren't all able to be here. I know that some of you would have loved to be here but can't right now, and that's okay. But I really need you guys to just kind of do what you can on your own with these. So what do we know? What do we notice? What's going on here? Okay. So fairly quickly, most of my students realized that this one and this one are actually more similar than these two are. So we went from here to here for most of my students, and they realized that to get from here to here, you would have to times by 2. From here to here, you'd have to times by 2. So that would mean that getting from here to our question mark, you would also need to times by 2. Okay, that's not too bad. 19 times 2 would give us 38. So that was this question mark right here. But then the next question is, what is 2 squares and what is 1 square? So now we kind of have to start over and think to ourselves, okay, what do we do now? Okay. So what do we notice? What could possibly help us with this? Okay. So a lot of my students were realizing that to get from here to here, it's the same there, but you would have to add 7 there, and you have to add 2 squares here. Well, then that would mean that 2 squares is 7, and if 2 squares is 7, then 1 square is 3.5. Okay. All right, let's do another hard one. Okay, on this one, I am not going to tell you the answer in this video. Use what we did on the last one. What did we do on the last one that enabled us to get where we needed to go? How did we figure it out? Could you do that on this one? Check. See if you can figure out how to do this one using the information that we learned from the last problem we did. Now, that being said, if you get stuck, the answer is up on Canvas. It'll be in my completed notes. But I think you can do this without. I really do. I think you can do this without me. Okay. Now, here's the kicker on this last one. On this last one, you are trying to figure out what 1 square is and what 1 circle is. Now, nobody in class had enough time to figure this out. I think people would have gotten there if they had had enough time, but we only had about 10 minutes left in class at this point. So I don't expect you to necessarily figure out exactly how to do this. But what I do expect is for you to take a couple minutes and really look at this and see, could I use any of the strategies that I had used previously on other problems to figure this out? Do any of them work? Do any of them not work? Why? Why don't they work? What's the problem? What's the same? What's different? Etc. And I just want you guys to really take the time and just really try to logic this out as much as you possibly can. Okay, and again, we didn't go over the answer in class. I didn't explain exactly how to do it. The only other thing we did in class is I did fill out this bottom section with them, and we actually skipped this one right here. Okay. So if one variable is the same in both equations, then the difference in total is due to the other variable. So this is like with the squares and circles on the first one. Okay. So because the squares are the same and these are different, then the difference has to come from this circle. Okay. So that's what this is saying. So this is like saying if one square is the same in both equations, then the difference in the total has to be due to the circle. Or vice versa. If one circle is the same in both equations, then the difference in the total has to be the squares. Okay? So that's how we figured out what these were, right? Well, you said, well, the difference is the circle, so that's got to be what this difference is. In this one, the difference was the two squares, so that's what that difference had to be from too. Okay? Now, if we know the total, we can also figure out the difference in any of these. If we know the total, then any difference of that amount is also known. Okay? So what we're saying is, if we know that this is 18.5 and this one's 14, we also know what's going on here. Okay? That's what we're saying with this stuff at the bottom. Okay, and I do want you to figure this out. Today I learned that, blah, 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 blah. What did you learn today about these? Okay? The sentence frames that I gave you on that green paper would also be really helpful on these. Okay, I wonder if. That would be great. I would love to see that on these. I already knew this. I expanded on that today by learning this. Okay, first we do this, then we do this, and then we do this. I noticed this, so we did this. Okay, something like that to add in here. Okay. If you have any questions, let me know, and I will see you guys all as soon as you're all back at school.